Hi, everybody. Today we're talking about transformation of functions, and we've done a lot with that, but this lesson is really a summary of that. So, first of all, I want to take a look at the summary sheet just to kind of remind you of what all the different ways that a transformation can be represented on a function. If we have a negative value, all right in out front, that means we're going to reflect over the x-axis. That means we would negate all the y values. If we have a value that is greater than 1 out front, we're going to have a vertical stretch. If it's between 0 and 1, it's a vertical shrink. If we have a negative here, all right there, that would mean that we're reflecting over the y-axis, and we would negate all the x values if we were looking at coordinates. A value of h shifts the function left and it shifts the function right. So if what is in the parentheses is x plus h, the whole function is going to go left. If what is in the parentheses is x minus h, that function is going to go right. And then at the very end here, we have this k value. That's going to move our function up or down. And just a little reminder, if we have a function, if it is a function and qualifies as a function, it's going to pass the vertical line test. Oh, and one more, this guy right here, don't want to forget that. If that value of b is greater than 1, it's a horizontal shrink. And if it's between 0 and 1, it's a horizontal stretch. So we're going to look at some graphs and we're going to apply some transformations and see how that affects the graph and how it affects the coordinates. Okay, so for number 1, it says, for the graph of y equals f of x, sketch all these transformations. So we have a graph and we have coordinates. So the first thing we want to do is we just want to fill in our table for the original function, and we want to just write down all the coordinates that we know we have for our graph. So we have -3, 3, we have 0, 3, we have 2, -1, and we have 5, 8. So for letter A, we're looking at y equals f of -x. Now that negative is inside the parentheses, right? So if you go back to our summary sheet, when the negative is inside the parentheses, that means that we're going to reflect about the y-axis and we're going to negate all the x values. So the y values aren't going to change. We still have 3, 3, -1, and 8. But all the x values are going to change signs. We're going to negate them. So we're going to have a -3, which is a +3. 0, we'll have a -2, and a -5. All right, at this point, we're ready to sketch our graph. We'll go ahead and do that. And you can see from the graph that we have reflected our graph over the y-axis, and that's what we were expecting because that negative was inside the parentheses. Right now, just for fun, we're going to put a negative out front this time for letter B. When the negative is out front, we're going to reflect the graph over the x-axis. If we do that, that's going to negate all the y values. So this guy, we negated all the x values. And for this guy, we're going to negate all the y values. So same x coordinates, -3, 0, 2, and 5. But we're going to change signs for all the y values. So it will give us -3, -3, 1, and -8. And we'll plot those and sketch the graph. And if we did it right, our graph should reflect over the x-axis. All right, and if you take a look at our graph, it has reflected over the x-axis. All right, letter C is y is equal to x plus 2. So we're inside the parentheses, it's a plus value, so that means we're going to move our entire graph left 2. All right, so if we're going to move our graph left 2 for letter C here, all right, what has to happen to the coordinates? If we want everybody to move left 2, we're going to have to subtract 2 from x. If we do that, then the whole graph will go left 2. All right, so what does that mean? We're going to subtract 2 from every x value. So -3 minus 2 is -5. 0 minus 2 is -2. All right, 2 minus 2 is 0, and 5 minus 2 is 3. And then our y values don't change. They're still going to be 3, 3, -1, and 8. And we'll plot those, and if we did it right, our whole graph should move to the left too. Okay, so it looks like we accomplished our goal there. Now, part D here. Part D, now we don't have the 2 inside the parentheses, it's outside the parentheses. That means that our function is going to move up and down. All right, so we're going up 2. And think about what that means. If we want our whole function to move up 2, we want all the y values to go up 2. So we're going to add 2 to y. So our x values will remain the same, but we're going to add 2 to all the y values. So 3 plus 2 is 5. Again, 3 plus 2 is 5. -1 plus 2 is 1. And 8 plus 2 is 10. And then we'll plot our points and see if we accomplished our goal. All right, and if we compare this to our original graph, you could see our whole graph did shift up 2. All right, moving on. It says consider the function f of x is equal to x squared. All right, so this is just IB notation. This is just saying that the function f of x is equal to x squared. So the first thing that we want to do for this guy is we want to graph the parent function. That'll just help us, do everything else. So we're going to put that right here, y equals f of x equals x squared. And we'll just pick some points, easy points. I'm going to pick -1, 0, and 1. And I'm going to draw that graph. Okay, once we've graphed the original function, now we're going to see what happens with these transformations we're applying. So the next one is y equals 3 times the whole function. So that's a value that is in front of the function. That's going to cause a vertical stretch. All right, so we're stretching our function up by a scale factor of 3. So let's make a note, vertical stretch of 3. And if we're going to stretch our function vertically, that means that we are going to be multiplying all of our y values by the value of 3. So we'll write our original x values, and then we're going to multiply all our y values by 3. And let's go ahead and draw that graph, and I'm going to do this graph in red. And now that we have our graph drawn in, you can see that it has stretched vertically upwards. All right, the last one we have here is, we have a lot going on this one. Y equals 3, the function. So we have a vertical stretch of 3. We have a shift of right 1, and we're going up 2. So we're going to go ahead and apply all of those transformations. We're going to multiply all our y's by 3. All right, this is saying a right 1, so that means we're going to add 1 to all our x values. And this is moving our graph up 2, so we're going to add 2 to all of our y values. All right, so our new x values are 0, 1, and 2, and our new y values are 5, 2, and 5. So I'm going to go ahead and plot those. All right, and if we look at this graph, it looks like we have stretched vertically, right? We've moved our whole graph over 1, and we've shifted our whole graph up 2. All right, number 3 is a slightly different take on things. We're not looking at a graph. We're actually like taking a function, just the equation, and rewriting the equation to show how we're moving our function, how we're translating it or stretching it or reflecting it. So for letter A, we're translating this function 3 units downward. So we have our new function, g of x, where we're going to take that 4x minus 7 and we're going to translate it 3 units down, which means we need to subtract 3 more. So that new function becomes g of x is equal to 4x minus 10. All right, that's letter A. Letter B, we have our new function that we're going to vertically stretch with a scale factor of 5. When we're vertically stretching, we have a value that goes in front of the function. So our new function, g of x, is going to be a 5 out front times the original function. So g of x in this case is 5x squared plus 30. Letter C, we're translating our function 4 units to the left. So that means wherever we have an x, we have to put inside the parentheses a plus 4. So g of x is going to be equal to 7 minus 3 times x plus 4. And we'll just clean that up. All right, letter D, we have a horizontal stretch with a scale factor of 3. Now, this is a little sneaky, all right? A scale factor of 3 for a horizontal stretch. Well, a horizontal stretch is going to be a number between 0 and 1. And they're telling us our scale factor is 3, which means if we're talking about a horizontal stretch, we're talking about putting the value of 1/3 in front of all our x values. So wherever we have an x, we're replacing it with 1/3 x. And then we just want to clean that up. All right, these types of problems really do ensure you understand how transformations work. All right, last one, letter A. We're reflecting about the y-axis. When we're reflecting about the y-axis, that means that we are putting a negative value inside the parentheses next to our x. So our new function is going to be negative x cubed. And we can simplify that. If we have a negative value, this -1 out front cube, that's just going to leave us with a negative. So either way is okay here, but I'm just going to write that as negative x cubed. I like that better. Take the parentheses out. If you can, for number 4, I would stop the video and I would try them and then come back when you're ready. All right, so first we're going to graph the original function. I'm going to pick some really easy points. I'm going to pick -2, 0, and 2. All right, next I'm going to graph letter A. So we've got y equals negative f of x. When that negative is out front, that means that we're going to reflect over the x-axis. So that means that all the y values become are negated. So we're going to write negate y. The x values remain the same. All right, I'll do this guy in red. And if we did this correctly, we should have reflected perfectly over the x-axis, and we did. For letter B, we have y equals f of 2 times x. So what's happening here? In this case, we are multiplying we have a horizontal shrink value. So this one's very sneaky, okay? When we have that 2 in front, keep in mind, what does this mean? That's the first thing you want to think about. And when it's a value greater than 1, it's a horizontal shrink. So if it's a horizontal shrink, that means that we need to multiply all of our x values by 1/2. If we multiply it by 2, that's going to be a stretch. Okay, so our x values are going to all be multiplied in this case by 1/2. The y values will just remain the same. And I'll do this graph in blue. All right, last one here, letter C. We're going to take our whole graph and we're going to move it +3. So that just means we're going to move it up 3. So we have to add 3 to the y's. All right, and I'll do that in, let's do it in blue. All right, if you compare that last one to our original graph, you would see that we've simply taken that original graph and moved it up 3. Number 5 involves the domain, right, which whenever we start talking about domain and range, everyone gets very nervous, but don't worry, not to fear. The function f of x has a domain. So this reads, x is the set of all values greater than or equal to -2 or less than or equal to 3. And for the range, the y values are from the set where y is greater than or equal to -1 and less than or equal to 7. Find the domain and range of g of x equals to x plus 3 minus 4. All right, so what's happening with the first one when we're talking about +3, right? That +3 means we have to move left 3. If we're moving left 3, we have to subtract 3 from the x's. That -4 means we're going to go down 4. So that means that we're going to subtract 4 from the y's. All right, that's not so bad. So our domain is being changed by going left 3, and our range is being changed by going down 4. So we'll rewrite our domain. Let's use our fancy notation. X is from the set, and now we're going to subtract 3 from -2, so we get -5. Subtract 3 from 3, so we get 0. And we've rewritten our domain based on those translations. All right, now we're going to rewrite our range. Y is from the set, and we have y is going to be greater than or equal to or less than or equal to our new values. Now remember, we're subtracting 4 from the y, so we have -1 minus 4 and 7 minus 4. So that's going to give us -5 and 3. All right, not so bad. We like that. Number 6, the graph of the function x plus 1 squared plus 4 is translated 2 units to the right and 4 units up. Find the function g of x, so we're going to rewrite that, and then we're going to state the range of the original function and the new function. So first let's do letter A. And we're getting good at this, so we're not worried at all. But inside the parentheses, that is going to mean we're going to do -2, right? Because inside is going to be the opposite. We're going to do x plus 1 minus 2. Then we still have our +4, and that 4 units up means that we're going to add 4 to y. So we already had a 4 out here. We have to add another 4. And then when we clean that up, we get g of x is equal to x minus 1 squared plus 8. Now we're going to be talking about the range. So let's see, letter B. We want to know what is the range of the original function. So the original function, the range, this function, right, the original guy started at a value of 4, right? So the original function took this, here's our parent function. Let's go this route. Here's our parent function. And by looking at the way this is written, this parent function went left 1 and up 4. So it went left 1 and up 4. From 4 up. Okay, so let's write down that range, the original function. Y was greater than or equal to 4. Now for the translated function, and we want to look at this now, right? This function moved right 1 and is up 8. So this outside value for when we're talking about a parabola, right, a quadratic, x squared, it moved the whole function to 8, so it's greater than or equal to 8. Okay, for number 7, the graph of f of x is translated by the vector -1, 3. And we're going to write the equation of the image in standard form. So what you're seeing here is what's called a translation vector. So the vector is moving this function left 1 and up 3. Right? So when we are rewriting this function for g of x, we're going to put x plus 1 inside the parentheses because we're moving the whole function left 1. And then we're going to tack on a plus 3 at the end because we are also translating the vector up 3. So let's go ahead and do that. So anytime we have an x, we're going to do x plus 1 because we're moving the whole function left 1. And then we're going to tack on that plus 3 at the end because we're moving the whole function up 3. And they're asking us to put this in standard form. So I would say pause the video here and see if you can simplify it and put it in standard form. So our final answer should be 3x squared plus 5x plus 9. For letter 8, find the equation of the line that results when the line f of x equals 3x plus 2 is translated 2 units to the left and 6 units up. Part B, show that the linear function ax plus b, where a is greater than 0, is translated k units to the left. The resulting line is the same as when f of x is translated ak units upward. All right, so letter B is one of those typical IB questions that you read it and you just think, I have no idea what they're talking about. So it says show that when the linear function, and they give you this function ax plus b, is translated k units to the left. And I want you to look at, I've done the work here for this just to kind of have the work as I talk through it. So if we're going k units to the left, that means that we're having a plus k in the parentheses. The resulting line is the same as when the function is translated 8k units upward. So if I rewrite my f of x equals ax plus b, and I just put in that plus k, I distribute the a, and then I rewrite it. All right, we basically have proven the point that the linear function f of x equals ax plus b is translated ak units. Now, this is not something I am going to put on a quiz or test. The reason I have this in here is because I want you to see that you're going to get these types of questions from IB. And sometimes all you can do is just start somewhere. So I just, basically took what they gave me and just worked through, distributing and moving things around the best I could. That's all you can do sometimes. So this is really more exposure problem than anything to anticipate on something I would put on your test. That would be a little unfair. This one even made me stop and think. Okay, number 9 says, consider the function, find the function which results with the following translations. So we have reflected in the x-axis and then translated using the translation vector. So the translation vector tells us that we're going to be moving left 2 and up 3. And we're also reflecting over the x-axis. So for letter A, because there's a reflection over the x-axis, we're going to have a negative out front. Because we're moving the whole function left 2, we're going to have an x plus 2 inside the parentheses, and then a plus 3 on the outside. For letter B, we're using the translation vector for negative 1, so that means we're going to go right 4 and down 1. And then we have a vertical stretch with a scale factor of 2. So that one, when we have a scale factor of 2, we're going to start with that. That's going to go in front of the function. Because we're moving the whole function right 4, we're going to say x minus 4 inside the parentheses. And down 1 is going to give us minus 1. Right, so that's it for number 9. All right, last one, number 10. Suppose the graph of y equals f of x has x-intercepts -5 and 1 and a y-intercept at -3. What can you say about the axes intercepts? All right, so for letter A, let's write this down. We have y equals f of x plus 4. Right, now we know that this function is going to go left 4. So if we're going left 4, that means that we're going to subtract 4 from our x-intercepts. So our new x-intercepts are going to be -5 minus 4 and 1 minus 4. And the y-intercept, all we can tell you is that the y-intercept changed, it shifted. We don't know what it is, though, because we don't know what the original function is. All right, so that's something we can say for sure. The x-intercepts became -9 and -3, but the y-intercept, all we really can say here is that it changed. Okay, letter B. Y equals 3 f of x. Now, when that 3 is out front, that means we are going to multiply all of our y values by 3. Right, so our x-intercepts don't change. They're just still going to be -5 and 1. But our y-intercept of -3 is going to be multiplied by 3. All right, letter C. We have y equals f. I'm going to rewrite this as 1/2 x. That'll help me out a lot. And that means that we have a horizontal stretch. So that means that we're going to be multiplying our x values by 2. Right, so our x-intercepts are going to be being multiplied by 2. So we're going to get -10 and 2. And our y-intercept is going to stay at -3. In part D, we have y equals a negative out front. And we know that that just negates all the y values. So our x-intercepts stay the same. So our x-intercepts here stay at -5 and +1. Our x-intercepts are at -5 and 1. And our y-intercept just gets negated. So that just becomes 3. There was a lot to this whole lesson, actually. So we're going to do a lot of practice on this. Don't worry. All right. Thanks for watching through to the end. Have a great day.